Thank you, Kevin. Good morning. 100 million plus weekly downloads across Python, Java, and Node. Imagine, that's how far we have gotten. It's great to see all of you here. This year, we are celebrating 10 years of the project. And later today, Richard is going to talk a little more about the context and history. I just wanted to take a minute to sort of remember back in 2014 when a lot of the foundational work on the project was happening. That was the year we formed the team and we designed the protocol. And we spent so much time debating the nuances of flow control and whether or not we should layer gRPC on top of HTTP2, and the fact that there were some compromises, like HTTP2 wouldn't do flow control for headers, and we felt that was a big gap, and so on. Well, we made the trade-offs we had to make, started building. We went live in 2015, and we were off to the races. And here we are today, 10 years later, with 100 million plus weekly downloads. Today, gRPC is a key building block for distributed systems across a variety of use cases. We have a broad adoption throughout the industry. It powers everything from databases to e-commerce retailers to banks, CNCF projects, to AI training and inference systems. So even though gRPC is so successful and is sort of the de facto choice for building a lot of these systems, it's useful to step back and think about it from different perspectives. And I like to, every time someone asks me what is gRPC, I try to give them one of these three perspectives depending on what they might care about. So I'll quickly go over all three. So the first is, gRPC is a protocol. It is a formal specification for interoperation across RPC systems implemented in different languages. A lot of it is under the hood, and a lot of developers don't have to care about it. And that's actually a testament to how successful the project has been at hiding the low-level networking details from the users. I mentioned flow control. Bidirectional streaming and flow control used to be real challenges for RPC systems, and controlling the memory in cases where you wanted to have a lot of requests in flight was not an easy thing. Today, you get it out of the box with gRPC, and 90% of the people don't even have to think about it at all. And that is proof that we have successfully solved that problem. But stepping away from the protocol, for a lot of developers, gRPC is really a framework. It's the thing they use to build their applications and services in the language of their choice. It's polyglot. It gives people a choice of language. So you can build using the right tool for the task at hand. If you have image processing libraries in Java and you need to do some image processing work, maybe you build your service in Java. If you have some need for some Go libraries, maybe you build your specific service in Golang. And they can talk to each other and interoperate very well. And that makes the life of application developers really easy. Of course, in every language, the team strives to deliver APIs that are idiomatic. And it comes with a set of features that is comprehensive enough that you can get going and build and focus just on the business logic while allowing gRPC to deal with a lot of the lower level details. The final perspective I'd share is gRPC also provides enables an architectural pattern, that of microservices. Microservices allow teams to break down problems into encapsulated small services, which talk to each other to together solve a bigger problem. This enables better developer velocity across larger organizations. And we see this become really relevant once you have an organization size, once your org size starts exceeding 30 to 50 software developers. That's where the benefits of being able to break down monoliths into smaller services really start kicking in. That's where gRPC really enables smaller teams to move in parallel at high velocity and deliver a lot of velocity for the organization. As these deployments grow, different teams and organizations that start out with gRPC start needing a lot of the service mesh features that gRPC comes with. And this is where sort of the choice to build on top of gRPC really starts paying off, because gRPC comes out of the box with a large number of features, everything from discovery and load balancing features that allow you to run large-scale systems, to built-in security. gRPC supports both authentication and encryption at the transport level, and authorization both at the connection level and at a per request granularity. There is support for observability, metrics, logs, traces across a variety of open source systems and cloud services. There's a large number of advanced traffic management features, which again don't matter till they matter. And once they start mattering because your service has reached that scale, it's really valuable to have all of those built in. And all of this is riding on top of a code base that is built for scale and is exercised in production by a large number of organizations, everything from small single application organizations or even open source teams, all the way up to cloud hyperscalers that are using gRPC as part of their infrastructure. And all of this is supported by community. It's this community here that contributes to both the growth and the adoption of gRPC. Over the past year, we have seen community engagement continue to ramp up. Kevin mentioned all the contributions that Antoine has been making from Datadog. We have seen a number of contributions come out of Spotify across different languages. Paul from LinkedIn has been contributing pretty significant performance enhancements in Golang. And all of this has enabled us to continue to ramp up our support across the languages that we have. A couple of years ago, we started hearing about the community interest in Rust. Over the past year, we spent time talking to Lucio, who had one of the most popular Rust implementations of gRPC. And we have a plan now to bring it into CNCF and drive all of the interop and feature compliance to provide a really first-class experience for Rust developers for gRPC. So I would like to thank all of you for all of the feedback and the contributions. Please keep the feedback coming. A lot of the team will be around today. When you run into them, please give them your feedback. Please think about contributing more directly to the project. And with that, I'll thank all of you and hand it back to Kevin.